So in this section, section 1.5, we are going to be working application problems. So notice it says we're going to be doing word problems with quadratic equations. So we're going to wind up with squares in most all of our equations. So the first one is something that my daughter did when she worked as a press brake operator. So she had a piece of machinery that produced rectangular sheets of metal, and that length was twice, the length is twice the width. So you can see that my lab will, a lot of times will go ahead and label some of this for you. Um, then we are going to take equal size squares measuring 10 centimeters, and we are going to cut them from the corners. So we're going to take these and we're just going to cut them out. So that's going to be gone, this is going to be gone, this is gone, and this is gone. So we wind up really with just a piece of sheet metal that looks like this in the blue. All right, and then we're going to fold those pieces up and create this box. Okay, so usually, or a lot of times, they do not give you this length right here. And they don't give you this length. You have to calculate it. In this example, they actually gave it to you. But let me show you how we came up with it. So we're going to cut those 10 centimeter squares off of each side. Then we're going to fold it up, make that box. And the volume of this box is going to be 7,500 centimeters. Okay. So notice that if I have this length that is 2x, and I cut off 10 centimeters here, and I cut off 10 centimeters here, what is left is my 2x minus those 10 centimeters. So that would be 2x minus 20. And I do the same thing on the right hand side with this one. I'll do it on this side since it's labeled. So there's my x. I take off that 10, I take off that 10, and what's left is x, my x minus the 2 10s, or x minus 20. So when you fold that up, there is the length, 2x minus 20. There is the width, x minus 20. And then the height, when you fold it up, it's just 10, there's 10 centimeters. So I wanted to make sure you saw how to get those in case my lab does not give that to you, or I don't give it to you on your test. So they told us that the volume of the box is 7,500 centimeters cubed. So if you remember, volume is just your length times your width times your height. So that's what we're going to do. We're going to multiply the length times the width times the height to get our volume. So volume is the length times the width times the height. And notice that they gave us the volume, so I'm going to go ahead and write that in, 7,500 centimeters. So to solve this for x, first thing we've got to do, remember what we need is x equals a number. That's what we're going for. And notice that's not going to give you any parentheses. So we need to get rid of our parentheses. So I'm going to do that first. I'm going to do this part first. And so that's going to give me 2x squared minus 40x minus 20x plus 400. And I get that by distributing. Okay, and then I'll have times 10. I can combine my middle terms. So that'll be 2x squared minus 60x plus 400. And again, that's times 10. So let's go ahead and distribute my 10 across. So that's 7,500 is now it's going to be 20x squared. Notice I'm multiplying each thing. 60 by 10 will give me 600. 440 times 10 will give me 4,000. All right. So now I've got a squared. Okay, but I need to set it equal to 0. So I'm going to move my 7,500 on the other side. And I'm going to wind up with 0 is 20x squared minus 600x minus, what's that, 3,500? All right, now I could just go ahead and start putting that into my quadratic formula, but that's some pretty big numbers. So let's see if they have anything in common. If you notice, 20 will go into everything. So I could factor it out, or I can divide. Either way, I think I'm going to divide. So if I divide by 20, and I divide that side by 20, I still get 0. So now I get x squared minus what? 30x minus 175. And now I could use the quadratic formula, or you can actually factor that. So when we factor it, we've got to get numbers that when you multiply them together, you get 175. So 5 goes into that 35 times. And that's how I got that minus 30. If you don't remember that, you can keep trying, or you could just use the quadratic formula. Either way, I want that negative 30x, so I'll put the negative with the positive 35. And then I get that plus 5. So if I fold that back out, I should get what I started with. So that gives me 2 answers. If I set each of those equal to 0, you don't actually have to show me this part, because some of y'all might be able to do that in your head. And subtract 5 on both sides. So I get x is negative 5, and I get x is 35. So now let's talk about these 2 answers. We started with a squared. So when you start with a squared, you are going to have 2 answers. But let's see if they both make sense. X equals minus 5. Can the distance here be negative 5? You can't ever have a distance of a negative 5. So even though mathematically it works, in reality, you can't do that, okay? So I know that this is now 35 centimeters, and then this one is 2 times 35, so that's going to give me 70 centimeters. So my rectangular piece of metal has to be a 35 centimeter by 70 centimeter piece of metal. All right, let's keep going. We might as well keep going using geometry. So volume a lot of times is used in geometry. Well, so is the Pythagorean theorem. Now, Pythagorean theorem, you may have heard a squared plus b squared equals c squared. I like to think of it as a leg squared plus a leg squared equals this big hypotenuse squared. So what most people miss when they're doing these problems with the Pythagorean theorem is they take this hypotenuse and they put it over here with a leg somewhere. So this long one has to always be by itself, okay? So the long one by itself, and these legs, it doesn't matter which order you put those in. So just make sure that the long one is squared by itself. Okay, so now we have a piece of property that has a shape of a right triangle. So if I did not already have it drawn, I would draw a right triangle. The longer leg, and remember when we talk legs, this is a leg and that's a leg. So the longer leg, so that's this one, is, is 10 meters shorter than twice the length of the shorter leg. Whew. All right, so when it says it's 10 meters shorter than, when it starts talking about the shorter leg, I'm going to let that be my x. So that's what we did. We put an x right there. And then this long one is 10 meters less, so I subtract it from twice this x. So that's how I got to 2x minus 10. And then finally, my hypotenuse, it says the hypotenuse is 20 meters longer than the length of the longer leg. So I put the longer leg, there it is. Put that up there, and then it's 20 meters longer. So that's where I added my plus 20. All right, so now I have, so I know that all the sides are labeled. So now we're going to use the Pythagorean theorem, and that's just leg squared plus leg squared equals the hypotenuse squared. So I'm going to do my first leg, x squared, plus my next leg, 2x minus 10 squared, equals my hypotenuse squared. Now, before I put this over there, I'm going to simplify it a little bit. So 2x minus 10 plus 20 is going to be 2x plus 10. Then I'm going to square it. All right. So now, again, I've got something squared. So I need to get it no parentheses and set equal to 0. So I'm going to go ahead and keep that x squared. I'm going to square this guy. So I'm going to do that over here if y'all don't mind. 2x minus 10 times 2x minus 10 is going to give me 4x squared minus 20x minus 20 more x's plus 100. That's what we get by foiling it. I'm going to simplify the middle part. 4x squared minus 40x plus 100. So that's what's going to come over here in the middle. I'm going to do that. So 4x squared minus 40x plus 100. And then we're going to do it again, except this time it's going to have a plus 10. So I just write it. Notice I'm writing it out twice. I don't just distribute that squared. That is not mathematically correct. So anyway, so I'm going to get my 4x squared. I'm going to wind up with 40x in the middle. So you could full it all the way out, but I'm just going to, I went ahead and simplified it in my head. So I've got 4x squared. Instead of the minus 20 and minus 20, I got plus 20 and plus 20. So that's going to give me plus 40x plus 100. All right, so I need to get everything to one side. So if I subtract my 4x squared, this one, if I subtract it to move it over here, do you notice that that 4x squared and this 4x squared are just going to cancel out when I subtract them? Do you see another one that happens with? Do you see this is 100 and that's 100? So when I subtract 100 minus 100, those are going to cancel out. Now, when I move my 40x, a lot of folks will cancel those out, but they don't cancel because I don't have different signs, right? So with this one, I have a plus and a minus, and same thing with this one. I had a plus and a minus, but now I have two minuses. So that's going to wind up being x squared minus 80x equals 0. And notice, now I can actually do this by factoring. I don't really have to do the quadratic formula because if I take out an x, I get x times x minus 80. So if I set each of one of those equal to 0, that gives me two answers. I don't really have to set them equal to 0. I can just look at it and say, I know this is 0. What would make my x minus 80 equal to 0 if that x was 80? All right. So once again, that is mathematically what it is. Okay, let's see if it actually, if all those answers make sense. So let's look at this first one. X equals 0. Does it make sense for that short leg to be 0? No, because if that's 0, then we don't have a triangle, right? So that is actually not going to be, doesn't really apply to this problem. So x has to be 80. So this is 80. So then I can figure out what this guy is. 2 times 80 minus 10. So that's going to be 150. And all these are what? Meters. And then this one is going to be 2x plus 10. So 2 times 80 plus 10. So that's going to be 170 meters. All right. Now, this next one, the height of an object, of a projected object. So we're going to throw some things. Just so you know, we're going to be throwing a lot of things in this class. So you're going to have this type problem on Chapter 1 test, Chapter 2 test, maybe even Chapter 3 test, and it's definitely going to be on your final exam. So we're going to be throwing lots of stuff. So a projectile, something, a ball or a rocket, something is launched upward from the ground with an initial velocity of how much? Initial velocity is 75.3 meters per second. So that's how hard it's being thrown. Neglecting air resistance. Air resistance, if you put that in, you need some calculus. Anyway, okay, so its height in meters above the ground, t seconds after it's thrown, is given by this guy. Okay, now this right here, minus 4.9, that is gravity. But we are talking meters per second, so we must be over in Europe somewhere. So that's gravity in Europe. That's not gravity here. Gravity here is minus 16 feet per second. Anyway, but so we're in Europe for this one, but that's okay. All right. So notice that this one, there's the 73.5 from, that's your velocity. And notice it is coming from the ground. So if it was coming from, say, the roof of a building, then I would say plus, 80 feet or wherever you're throwing it from. But since it's from the ground, we're not going to add anything to that. All right, so here's my formula. And they said, after how many seconds to the nearest hundredth will the projectile be 100 meters above the ground? So this is your height. They said let the height be S. If you don't mind, I'm going to change that to an H because that makes more sense to me. So if I put the time, let's say 2 seconds, 2 seconds after I launch it, if I throw 2 in there and I crank it out, do plug and chug, that'll tell me the height of that ball or whatever it is after 2 seconds. They're wanting to know the height, they're wanting to know how many seconds. So they're wanting to know the time that it will be 100 meters above the ground. So the 100 meters is my height. So I'm going to put 100 meters in there for the height. Then I have the rest of this, 73.5 T. All right, now we've got a square. So I need to solve it for that square. So we're going to either use the quadratic formula, completing the square, or factoring. I'm going to move, but either way, I got to move that 100 on the other side. So when we move it to the other side, we just do the opposite, right? We subtract 100 on both sides. So I'm going to have minus 100 right here. Now, I'm not going to factor that thing because it's got decimals in it. So I'm not going to factor it. Could do the quadratic formula. Completing the square, but that's a little bit hard to do. So I'm going to do the quadratic formula. Okay. Now, I'm actually going to work it using quadratic formula right now. Eventually, in the next, couple of class periods, you're going to see me just say, we use the quadratic formula and we got this, okay? But for right now, I'm going to actually plug it in and show you how to do it. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. There we go. And now we have, here's our a, here's our b, and here's our c. If it helps you to write it out to the side, go right ahead. So I'm going to plug it in, negative 73.5 plus or minus the square root of 73.5 squared minus 4ac. My a is negative 4.9. My c is negative 100 all over 2a, and my a was negative 4.9. All right. I do not want y'all coming in here and trying to figure out that and then do the square root. And you've got a fancy schmancy calculator. We are going to use it. Okay. So I'm going to show you how to enter it into your calculator. Okay. There's a couple of different ways, and it depends on your calculator. First thing I want you to do is I want you to hit alpha y equals on your calculator and see what happens. So if you don't have your calculator out, feel free to pause this recording and then try it. Hit alpha y equals and see if you get this n/d, whatever. That means you can write it as a fraction. So if you can write it as a fraction, we're going to hit that. And do you see how it separates it into a fraction? So if yours does that, then all you have to do is start sticking it in. So I'm going to put a negative. Notice I didn't put a minus. If you use the minus sign, that one right there, if you use the minus sign, it's going to mess it up, okay? So just like it did that. So we don't want to mess it up. So we use the little negative sign down there next to enter. And I'm going to put 73.5. I'm going to put plus this time. Then the square root, your square root button is on the left-hand side. You see x squared? It's right above what says log. There's an x squared, and above that in the blue is a square root. All right, so let's hit that second and x squared. That gives me my square root. I'm going to put 73.5. My squared, I go back to that same place and just hit squared. minus, this is an actual minus, 4 times negative 4.9, close my parentheses, open my parentheses again, and get negative 100. I'm going to close my parentheses, and I'm going to come down here to the bottom and do 2, and then times negative 4.9, and close my parentheses. Okay, I'm going to go ahead and hit enter. So that gives me an x of 1 point, did they say to round it to the nearest hundredth? So here we go. Here's my tens, hundreds, thousandths. So when I round it, that's not going to go up. So it's going to be 1.51. So almost 1.5, a little bit more than 1.5 seconds. All right. Now, let me show you something. If you hit alpha y equals and you do not get that fancy thing that I had, okay, that's not a big problem. All you have to do is you've got to add in some parentheses, okay? So if that is your case, you're going to make sure before you do anything, you're going to put parentheses here, then enter everything that I have, and then you've got to close that parentheses. Okay, I'm going to put a star there because what I want you to notice, do you see that I've got a parentheses here and a parentheses here? So you're going to have 2 in a row, okay? And then you'll put your division sign, and then you'll put another parentheses here and another parentheses there. So you're going to have a lot more parentheses than other folks. Everybody can count their parentheses before you hit enter. If you have an even number of parentheses, you're golden, usually, okay? But if you have an odd number, that means you left something off, okay? So I'm going to go ahead and put it in like I just told y'all for those that do not have that fancy schmancy calculator. So let me do that, plus the square root of 73.5 squared minus 4 negative, whoops, I don't want to put a minus, negative 4.9 and negative 100. Okay, something happened. 100, there we go. That's weird. Sorry about that, y'all. Let me come back over here. It's not doing it. I don't know why I did those decimals. Maybe I put in decimals. Okay, so close my parentheses. Then I'm going to hop out. Okay, so I hit my little right arrow button, and now I'm going to put another parentheses. Okay, now put a division sign, and then put another parentheses, 2 times negative 4.9, and close my parentheses. When I hit enter, I get the same exact thing. Okay, you just have more parentheses. Now, let me show you something cool no matter what. Okay, I don't want to have to put all that back in again. So I am going to hit second and enter. And look what happens. It doesn't matter what kind of calculator you have. Let's do second and enter. Do you see that it put the exact same thing back on my screen? Okay, and then all you have to do is just scooch back over there to where the plus sign was. Let's get back over there. Once you get to the plus sign, hit delete and put a minus sign. And then you just hit enter again, and that gives you your next one. 13.486. 13.486 something, something, something. And so that one will round up. So that's going to give me 13.49 seconds, so almost 13.5 seconds. Now the question is, do both of these apply? Do I have 2 answers? Now it says I do because I have x, t squared, but mathematically do I do? Do I have 2 answers? Well, let's think about it. I'm going to throw something up and it's going to come back down. Here's the ground. When is it going to be 100 meters? So here's my 100 meters. Do you see that it's going to hit there twice? So you're going to throw it, and then about 1.5 seconds, there's my seconds, 1.5 seconds, it's going to be at 100 meters, and then it's going to keep flying, and then it comes back down at about 13.5. ish seconds is when it's going to hit that 100 meters. Then it'll finally hit the ground. Okay, so it makes sense that we actually have two places that that thing is actually going to hit at 100 meters. Okay. All right. So this one says, how long will it take for the projectile to return to the ground? Well, let's look up here at my picture and let's see. I should have made this green, huh? That should have been green, not these guys. All right. So the ground's green. So there's two times that it's green, right? It's green here and it hits the ground there. Okay. So twice it hits the ground. Once before we even kick it off, and then when it's ground. Okay. Where is the ground? What is the height? Your height's going to be 0 at the ground. So I'm going to do the exact same thing that I did on part A, except instead of 100, I'm going to have 0. 0 is my height. Negative 4.9 t squared plus 73.5 t. Now, you could use a quadratic formula, but guess what? I don't need to. I'm going to factor it out because I've got a t. I can take a t out. All right, so now I have two things I'm going to set equal to 0. This one, t equals 0, which makes sense because time is 0 here, right? And then this one. So I've got negative 4.9t plus 73.5 is 0. Move that 73.5 on the other side, making it a negative, and then divide. And when you divide, believe it or not, you're going to get something sort of nice. I think it's 13 seconds. Let me double check. 15 seconds. So it's going to land in 15 seconds. All right. So it's not just throwing things that give us this kind of graph. Okay. Think about the sales of iPods. Okay. iPods, there weren't any. Then a few people got them because they had a lot of money. And so they were the first ones. And then everybody really liked them. So there was a huge surge in people buying iPods. And then the iPhone came out. And so everybody bought iPhones and the iPod sales went down. So it went way up and then it's going to come back down. So it's going to look a lot like when we threw stuff. So now we have our equation. Okay. So here's our equation. Notice that it has a squared in it. Okay. So we are going to be using quadratic formula maybe because it has decimals eventually. Who knows? So let's look. It tells us that this is the iPod sales from 2006 to 2014, where S is the sales in millions. So if I got an answer of 2, it would be 2 million. Here is a key thing. 0 represents 2006. So if I wanted to know, let's say I want to know what it's going to be in 2007, then if 0 is 2006, then 1 year later is 2007. That means I would enter, this is my T. I would put 1 in there. So if I want to know what it is in 2007, I would put 1 in for T. If I want 2008, I would put 2 in for T. So that's key because if you put in 2008, you're going to get this, not the right number. Okay. So let's see what it's asked. Use that model to estimate the sales in 2012. So we got to figure out what T is. Okay. So again, if 0 is 2006, then 2012 is 6 years later. So the T would be 6. If that's confusing, you can always just say, well, there's 3, when 2009, there's 4, 2010, could go all the way up till you get to 2012. Anyway, so all I'm going to do is plug in my 6 right where it has the X, both places. 6 squared, 6 there. So I'm plugging it in, and then once again, just plug that straight into your calculator, the whole thing, and you're going to wind up, let's see, you're going to wind up getting 37.16 something. And they want us to round it to the nearest tenth. There's the tenths. So that's going to move up. So it's going to be 37.2 million is what we project it to be. Well, 2012 has already passed, so they actually have data. So it was 35.2 million. They want us to compare the results. So if I take away 35.2 million, so we're off by 2 million. Say we're off by about 2 million iPods. So we were off just a, I mean, that's not a little, but compared to 37 million, 2 million isn't too bad. Okay. According to the model, in what year beyond 2006 did the sales reach 40 million units? So what is this 40 million? Where does it go? Is it our time, or is it our X, or is it our S? So they're saying this is the sales. So that's our big S. So we're going to put 40 equals, and now we're going to have our equation. All right. Now, before we can solve this, we got to set it equal to 0. So I'm going to subtract 40. And we'll get what? 2.8. All right. And then from here, you're just going to plug that into your quadratic formula. And this is one that I am going to just say plug into the quadratic formula. Okay. And when you plug it in, you're going to get two answers, negative 0.344 and 5.69, something, something, something. Okay. So, and all that is I'm going to take, this is my, here's my A, here's my B, here's my C, and I'm just going to plug it back up into that quadratic formula. Okay. So you need to try that. Make sure you do that on your calculator. Make sure that's what you get. Practice plugging it into your calculator. Okay. They want us to notice that we have a negative. Now, does it make sense to have a negative? I mean, that would just mean that it is before 2006, right? So it was 2006. So this negative 0.3, that's like a third of a year before. So that's 2005 and a little bit before 2006. Okay. But this is after, and that's what they said, the year beyond 2006. Now, my lab does this a lot, so I'm going to call your attention to it. Do you see that it says round down to the nearest year? It's specifically saying go down. Whoops, go down. I would not normally round that down. I would round that up to 6 years, but because they said go down, that is a trap. Okay, so we're going to go down to 5 years later. So what year beyond 2006? So I'm going to take 2006 and I'm going to add those 5 years. So that's going to give me 2011 is when it should have reached 40 million units. All right, we are almost done. We are talking about our consecutive integers. So consecutive integers, first you need to understand how they are put together. Okay, so a consecutive integer is one right after another, like this 5, 6, 7, 8. Those are consecutive integers, one right after another. So let's talk about how you go from 5 to 6. What would you add to go from 5 to 6? You would just add 1, right? So that's going to be x plus 1. Well, this next one, I'm going to start at 5 again. What would I add to 5 to get 7? I'm going to add 2, right? X plus 2. And then to go from 5 to 8, I'm going to add x plus 3. So anytime you have consecutive integers, 5, 6, 7, 8, 9, 10, 11, 12, 100, 101, 102, you're going to have x plus 1, x plus 2. Now let's look at consecutive even and odd integers. So let's go from 3 to 5. What do you add to 3 to get 5? We're going to add 2. To go from 3 to 7, what do we add? We're going to add 4. And to go from 3 to 9, we're going to add 6. Okay, let's do even. From 2 to 4, we're going to add 2. From 2 to 6, we're going to add 4. From 2 to 8, that's supposed to be an 8. From 2 to 8, we're going to add, what are we going to add? 6. I want you to notice that, whoops, let's come up here. Nope. There we go. Do you notice that these are exactly the same? To go from an odd to an odd or an even to an even, you're going to be adding even numbers. Okay, so most folks, when you're doing your working problems, whenever it says consecutive even numbers, people have no problem. X plus 2, X plus 4. Okay, but when they say consecutive odd and students put X plus 2 and X plus 4, which is correct, students get all worried and they're like, oh no, that's not odd. So I'm going to say X plus 1 and X plus 3. That does not work. Okay, so no matter whether it's even or odd, you're going to write down the X plus 2, X plus 4, X plus 6. Okay, so let's work a couple of these. Find two consecutive even integers whose product's 110. So when I first read this, the minute I see two consecutive integers, I don't read anything else. I say the first one is X, the second one is X plus something, and then I go back and look for the words even or odd. Well, they're not in there. So we want just consecutive integers. So I'll say X plus 1. If I had a third one, I'd say X plus 2. Anyway, all right, so I have them labeled. They want to know, find the two numbers whose product. Remember, product just means multiply. So I'm going to take these guys and I'm going to multiply them. The first one times the second one that's your equal mark, is 110. So now I've got my equation. I'm just going to distribute and now have a squared. I'm going to move that 110 to the other side, right? And we do that by subtracting it on both sides. And now we are ready to either factor it, quadratic formula it, or completing the square if you're crazy. All right, so if I can factor is a shortcut. So if I can factor, and think about this one, 110 is the same thing as 10 times 11, right? 10 times 11. And if I subtract that, I'm going to get a 1. So I could actually factor this. 10 times 11. I want a positive 1 in the middle. So that's going to be a plus, and that's going to give me my minus. So I get two answers. So this one, we talked about this in class, that you could actually, you don't have to write it down. You could say X minus 10. What would make that 0? That's if X was 10. And this would be, negative 11, if I set it equal to 0, right? If I said X plus 10 equals 0, X plus 11 equals 0, I just take my 11 and subtract it on both sides. Okay, so I will have students in my lab or on the test. I'll say find two consecutive integers whose product is 110, and I get a lot of students who say, oh, the answer is 10 and negative 11. Well, here's my question. Is 10 and negative 11, are those consecutive? They are not. So what this means is we have actually two sets of answers, okay? So my first set is X equals 10, and then I'm going to add 1 to it for the second one, right? So X plus 1 equals 11. So my first set is 10 and 11. My second set, do the same thing. X is negative 11. So my X plus 1 is going to be a negative 11 plus 1, which is actually negative 10, right? So my next set is negative 11, negative 10. So I actually have two sets of answers that both are correct. They're consecutive, and if you multiply them together, you get 110. All right, last one. And this one on your notes, it reads this. On mine, for some reason, it didn't. But it says the difference of the squares of two positive consecutive odd integers is 32. Okay, so first thing I noticed is we said two positive odd integers. Okay, so I've got two of them. So my first one is x. My second one is x plus something. I go back and I look, do I have odd ones and even ones? Yes, I do. So that's going to be x plus 2. Even though it says odd, we do x plus 2, right? So now they said the difference of, whoops, the squares of, so we're going to square these guys. So the difference of the squares of these two positive consecutive odd integers is 32. So now we just got to decide which one goes where. So am I going to put this guy, am I going to put this guy first, or am I going to put it second? Does it matter? Well, let's think. They said they wanted it to be positive, right? We want it to be positive. So for it to be positive, you're going to have the big one here and the little one here, right? Big one goes first, subtract the little one. If you do little minus big, you get a negative. So the big one has to go first. So which one is the big one? That's going to be my x plus 2. And the little one is going to be x. And now we're going to simplify that. I'm going to do this first. X plus 2 squared. X plus 2 and x plus 2 is x squared plus 4x plus 4. Or you could think x squared plus 2x plus 2x plus 4. All right, so I have x squared plus 4x plus 4. And I'm going to subtract my x squared is 32. Well, look at that. My x squareds are going to cancel out, right? X squared minus x squared. So now I just have 4x plus 4 is 32. Now I just have an algebra 1 problem. So I'm going to subtract. I get what's that, 28? And divide by 4. And I get x equals 7. And they want us to find both the integers. So this one is 7. So this one is 7 plus 2. So that's going to be 9. So my answers are 7 and 9. So that's the end of that section. And you are now ready to do your homework.